this video, we discuss how to determine critical points. So this is the graph. Okay, here is minimum, maximum, and corner of V point. When derivative equals 0, okay, this graph will look like a horizontal line. Okay, this is horizontal line. dy dx is equal to 0. dy dx is equal to 0. And derivative doesn't exist. We look like sharp point, or we'll call a corner of V point. Okay. Look at this graph. Okay. This graph. Maximum, minimum. Okay. Tangent lines with flat slope of dy dx is equal to 0. And this one. Okay. This one. Even though dy dx is equal to 0, that point clearly isn't maximum or minimum point. So we can conclude not all critical points are extremum. Okay, extremum means maximum or minimum. So this is we call actually point of inflection. Classification of critical points. Critical point. f of x is defined. The function is defined. So for critical point, it consists of two parts. The first is when f prime of x is equal to 0. This critical point also called stationary point. For this stationary point, it has a local extremum. Okay, so in your syllabus already discussed local extremum, minimum, local minimum, or local maximum. Okay, the rest is not in your syllabus. For f prime of x is equal to 0, local minimum is like this. Okay, the graph is like this, smiling graph. Okay, and then when local maximum, the graph is Z graph. And then for f prime of x is undefined or does not exist, this one only critical point. Then it has also local extremum. Okay, for local minimum, the pattern is V point or corner like this. Okay, so V point or sharp point or corner point. Okay, this is the critical point. So for this part, critical point and also stationary points. Okay, so look at the example. Okay, example. Given function f(x) is equal to x squared over x squared minus 49, find critical points. First thing, find domain. Domain of f. Okay, all real numbers except x squared minus 49 is equal to 0, x minus 7, x minus plus 7. So x is equal to negative 7 or x is equal to 7. So all domain of f, all real numbers except negative 7 and 7. So this is domain. Now we're going to differentiate f with respect to x. Okay, this is in the form of ratio. So use the quotient rule. Okay, f(x) is equal to x squared over x squared minus 49. This is u over v. The pattern is y equals u over v, y prime, using quotient rule, u prime v minus u v prime over v squared. Okay, and then u is equal to something. U is equal to x squared, v is equal to x squared minus 49, and u prime is equal to 2x, v prime is equal to 2x. Then using the quotient rule, up times and minus, and 2x times x squared minus 49 minus x squared times 2x over v is equal to x squared minus 49 squared. Okay, and then simplify. Okay, simplify. I expand, okay, and 2x cubed minus 49x minus 2x cubed over x squared minus 49 squared. Okay, and this one is equal, can be cancelled, and the answer is negative 49x over x squared minus 49. So now, okay, for f prime of x is equal to 0, okay, f prime of x is equal to 0. Okay, so this one critical point and also stationary point. Critical point and also stationary point. Okay, then it implies that this one is equal to 0. Negative 49x over x squared minus 49 squared is equal to 0. Or negative 49x is equal to 0. Therefore, x is equal to 0. Okay, and for f prime of x does not exist or undefined, to show this is only critical point. Okay, and when the function f prime of x does not exist or undefined, okay, it means that denominator x squared minus 49 is equal to 0. Then x, this one, x minus 49 is equal to 0. And now x minus 7, x plus 7 is equal to 0. X is equal to negative 7 or x is equal to 7. Okay, okay, negative 7 and 7 not in the domain of f. So this one cannot say this is critical point. Okay, then therefore, okay, this only critical point. Then find f of 0 is equal to 0 over 0 minus 49 is equal to 0. Therefore, 0, 0 is a critical point and actually also stationary point. Okay, settle. Example, determine the critical points of this function. Firstly, you need to differentiate this function. Okay, change in the form x squared minus 6x to the power of 1 over 5. Find the first derivative f prime of x. Using the power rule, 1 over 5 x squared minus 6x, okay, minus 4 over 5. Then differentiate inside here to x minus 6. Okay, and I over 5x squared minus 6x power of 4 over 5. To find the critical point, okay, so when f prime of x is equal to 0, first case, and the second case is when f prime of x does not exist or undefined. Okay, so now take this one. Okay, take this one. 2x minus 3 over 5x squared minus 6x power of 4 over 5 is equal to 0. Let's consider this one is equal to 0. Okay, is equal to 0. 2x minus 3 is equal to 0. Therefore, x is equal to 3. Okay, so next is this one. When f prime of x does not exist or undefined, okay, it happens when denominator is equal to, okay, so 5x squared minus 6x power 4 over 5 is equal to 0. So x squared minus 6x is equal to 0. Factorize. and then x is equal to 0 or x is equal to 6. So as you can see now here, okay, the numerator, this is numerator, okay, just take this one. Actually, this is not good concept. Just take this one to find f prime of x is equal to 0 to show that this is critical point and also stationary point. And take the denominator here and is equal to 0 to find the f prime of x. Okay, which is not defined. Okay, this is the way how to remember, but it's not the concept. Okay, you need to take all for f prime of x. Okay, this one is okay. Just take the denominator is equal to 0. This f prime of x is undefined or does not exist. Okay, so when x is equal to 3, okay, this is actually critical point and also stationary point. When x is equal to 0 and 6, this one only called critical point. Okay, and when f of 3, find the value to get the points. F of 0 and f of 6. Substitute in the function to get the points of critical points. Okay, that's all.